This nuclear rocket ship utilizes radioactive technology to reach the stars as it embarks on a century-long voyage to Proxima Centauri b. This rocket will achieve a velocity of 4.24% of the speed of light. Will the spaceship be able to fly through dangerous asteroid fields? And how will it keep its inhabitants alive?
Will there be population growth on the spaceship Stellara over the coming century? How does bacteria behave in a closed-loop system on the ship? And what level of time dilation is expected when they reach their new planet? Additionally, what preparations are made on the Stellara during the last 30 years of travel to help passengers adjust to the different conditions on Proxima Centauri b, including higher gravity and the red sunlight? Why is the Stellara spaceship destined for Proxima Centauri b? The reason is that it's the nearest habitable planet to Earth, located just 4.24 light-years away. Utilizing its nuclear fusion engines, the Stellara is set to reach Proxima Centauri b in a century. The spacecraft carries 1,800 passengers, with the journey starting now. Launch. The spacecraft, now in high Earth orbit, activates its nuclear fusion drive for launch. It undergoes a 15-day acceleration at 1g to attain its cruising velocity, which is 4.24% of the speed of light. Following this acceleration phase, the big spin is initiated. Spin. The Stellara, having surpassed Mars, is now advancing towards the asteroid belt. It took less than 2 hours for the spacecraft to pass the Moon, and a mere 14 days to exceed Mars's orbit, thanks to its nuclear fusion engine. The vessel's trajectory is inclined at a 21-degree angle beneath the solar system's ecliptic plane, an imaginary flat disk where Earth and other planets orbit the Sun. This course is set to align with the star system of Proxima Centauri b, which lies below this plane. 15 days post-launch from Earth, the engines have been deactivated. The Stellara is now sailing at 4.24% the speed of light, a pace it will maintain for 99 years. Now begins the spin maneuver. The thrusters on the perimeter of the Stellara ignite. The spacecraft, with a diameter of 750 meters, approximately 2,460 feet, twice that of an aircraft carrier, begins to rotate its outer ring. This rotation is designed to create 1g of artificial gravity, equivalent to Earth's gravitational force. To achieve this, the ring must spin at a rate of 1.9 rotations per minute. Once the desired gravity level of 1g is attained, the spin thrusters are switched off. Thanks to the principle of conservation of angular momentum in space, the Stellara habitat ring will continue its rotation for the remainder of the journey. Asteroid belt. 4 days after the big spin, the Stellara is now approaching the asteroid belt. This is not like the movies. The asteroid belt is not dense, and the asteroids are not close together. They are far apart. The average distance between asteroids in the asteroid belt is almost 1 million kilometers, 600,000 miles, which is over 2 times the distance between the Earth and the Moon. Even though the Stellara is traveling 2.1 degrees below the ecliptic plane, the majority of asteroids are within about 10 to 30 degrees of the plane. The spacecraft still passes through the asteroid belt. A path is plotted to avoid the asteroids. In any case, the Stellara has been designed with protection against asteroids and the future elements it will face. Now, with no more acceleration, the Stellara relies on its spinning motion to generate artificial gravity, exerting an outward force. This alters the orientation inside the spacecraft. What was once the walls of the spinning habitat ring now become the floor. Any windows incorporated in this new floor provide views as the habitat ring rotates around the Stellara hollow core. This central core remains gravity-free, as it does not participate in the spin. Serving as a crucial storage area, it houses cargo, including space shuttles intended for use by future generations of passengers at the end of the 100-year journey. Asteroid belt. 4 days following the initiation of the big spin, the Stellara nears the asteroid belt. Contrary to popular movie portrayals, the asteroid belt is not densely packed. The asteroids are widely spaced. In fact, the average distance between asteroids in this region is about 1 million kilometers, 600,000 miles, which is more than double the distance between Earth and the Moon. Despite the Stellara traveling 2.1 degrees below the ecliptic plane, the majority of asteroids in the belt orbit within roughly 10 to 30 degrees of this plane. As the spacecraft traverses the asteroid belt, a carefully calculated path is followed to steer clear of these celestial bodies. Additionally, the Stellara has been engineered with robust defenses against asteroid impacts and other challenges it may encounter in space. The Stellara is equipped with a fortified hull designed to withstand the impacts of interstellar travel. This reinforcement is crucial as the spacecraft encounters dust and gas clouds in space, which can vaporize and erode the ship's exterior. Over a distance of 4 light-years, it's estimated that about a millimeter of the ship's outer layer could be eroded by these particles. To mitigate the risks posed by larger micrometeorites, the Stellara employs tracking sensors and lasers. These systems detect incoming debris and actively deflect them, altering their trajectories to ensure they don't collide with the spacecraft. This technology plays a vital role in clearing a safe path for the Stellara as it journeys through space. The Stellara has now embarked into the expansive and mysterious realm of interstellar space, a region teeming with gas dust clouds, cosmic rays, and rogue planets located between the stars. This phase of the journey commenced just over a month after launch from Earth, as the spacecraft journeyed past significant milestones within our solar system. It navigated beyond the orbits of Jupiter and Saturn, with its majestic rings and even Halley's Comet. The spacecraft then traversed the distant Kuiper Belt, where Pluto lies, before finally crossing the heliopause, the boundary where the sun's solar wind is stopped by the interstellar medium. Having left the influence of our solar system, the Stellara is now voyaging through the depths of interstellar space, with its destination set for Proxima Centauri b. The command deck of the Stellara meticulously monitors the population dynamics aboard the spacecraft. Initially, 1,800 people embarked on the journey from Earth. Over the 100-year voyage to Proxima Centauri b, this number is projected to grow to just under 4,500. The population composition includes 1,300 adults, among whom 300 are parents of the 300 children already on board. It's estimated that approximately half of these children will reach adulthood within 10 years, while about 1/3 of the adults will transition into elder status every decade. The community respects an average lifespan of 80 years, with around 1/3 of the elder population, aged between 50 to 80 years, and esteemed for their wisdom and experience, passing away every 10 years. Concurrently, the onboard biologists diligently track the evolution of bacteria within the spacecraft. The concern lies in the fact that these microorganisms, reproducing and evolving at a much faster rate than humans, are part of a closed-loop system. Bacteria can undergo thousands, even tens of thousands of generations each year, depending on the species. This rapid evolutionary pace heightens the risk of mutations that could potentially lead to the emergence of pathogenic strains or a shift in the bacteria's role within the human digestive system, either of which could disrupt the ship's biosphere. Ensuring the stability and compatibility of these evolving bacteria with human life is a critical aspect of maintaining the health and safety of everyone aboard the Stellara. The first year aboard the Stellara is marked by a significant milestone, the birth of the first child in space, symbolizing the dawn of a new generation born during the interstellar journey. In this first year alone, 32 additional births have occurred, each celebrated as a momentous occasion. To honor these births, a small pebble from Earth is released into space with each new arrival, symbolizing a poignant connection back to our home planet. As the Stellara voyages further into space, the effects of time dilation become evident. Currently, the spacecraft is 0.424 light-years away from Earth, a staggering distance of over 4 trillion kilometers, 2.4 trillion miles. This vast separation results in a communication delay with Earth, taking approximately 5 months and 1 day for messages to travel one way. The relativistic phenomenon of time dilation is also noticeable. While 10 years have elapsed on the Stellara, 10 years and 3 days have passed on Earth. This discrepancy in time experienced between the spacecraft and Earth will continue to grow as the Stellara maintains its speed of 4.24% the speed of light for the remaining 90 years of its journey. Time dilation, a relativistic effect, can be understood through a simple analogy. Think of time as a river flowing steadily. If you're sitting in a boat without rowing, you move at the river's pace. But once you start rowing swiftly, it seems as though the river around you slows or even appears to flow backward, though this isn't the case for people on the shore. Both you and the river reach the same endpoint, but your experience of the river's flow is different. You age less because your segment of the river flowed more slowly for you. The question arises, how many additional days will have passed on Earth by the time the spacecraft arrives at Proxima Centauri b? During the first 10 years aboard the Stellara, the first deaths have occurred. In each instance, the body is released into space and the ship observes a moment of silence, followed by a reading. This reading reflects on their future home, Proxima Centauri b, acknowledging that the deceased has fulfilled their duty and their memory will eternally resonate on the new planet. Genetic diversity. As the Stellara reaches its 20th year in space, it welcomes the second generation of children born on board. With the population steadily growing, maintaining genetic diversity becomes a critical factor for a healthy and balanced population during the 100-year journey and beyond. This necessitates specific rules and guidelines on the spacecraft. Strict reproduction guidelines are in place to ensure equal genetic contribution from each family to future generations and to preserve genetic diversity. There are rules about family size. Families are encouraged to have a minimum of 2 and a maximum of 3 children. This policy aims to maintain a replacement rate for the parents while avoiding excessive population growth that could burden the ship's resources. Additionally, there's an emphasis on generational staggering, with parents encouraged to have children at different times. This approach prevents the formation of age clusters, avoiding large groups of children of the same age. Families are also strategically assigned to different areas of the spacecraft. The command deck manages a rotation system for living quarters, promoting interactions among individuals from varied family units, thereby facilitating a regular mixing of the gene pool. Moreover, when couples decide to have children, they undergo genetic counseling. Their genomes are sequenced and analyzed for genetic compatibility and to identify any potential health risks. All these measures are essential to prevent the potential collapse of the passenger population and ensure a genetically diverse and healthy community aboard the Stellara. In case of reproductive challenges or to further ensure genetic diversity, the Stellara is equipped with alternative reproductive technologies. The artificial womb lab is a significant feature, allowing for gestation outside the human body. Additionally, a stock of cryogenically frozen sperm and egg samples from Earth is available. These options play a vital role in maintaining genetic variety, especially crucial for the initial generations. Starting the journey with a genetically diverse population sets a strong foundation for its preservation throughout the 100-year voyage and in the future settlement. As the Stellara travels further into space, the communication delay with Earth becomes more pronounced. Now 1.27 light-years from Earth, it takes over a year for messages to travel one way. Meanwhile, the spacecraft is also 2.97 light-years away from Proxima Centauri b. During this time, the first generation of children born on the ship has grown into adulthood and is beginning to take on junior leadership roles and more advanced responsibilities. A significant milestone is reached with the birth of the 1,000th baby, who is also named Stellara, continuing the tradition of significant and symbolic names. Other popular names on the ship include Elysium, Helios, Surya, Apollo, Terra, Joro, and Centaur, reflecting a continued connection to Earth-based mythology and cultures. Amidst this journey, there's a growing conversation among the Stellara inhabitants about renaming Proxima Centauri b. The idea is to choose a name that resonates more with human or spiritual elements, reflecting the new life and civilization they aim to establish upon arrival. This discussion underscores the deep connection the passengers feel with their future home and their desire to make it uniquely their own. As the Stellara celebrates the 50th year of its journey, Reaching the halfway mark, a significant shift occurs for the passengers. Gazing out of the windows, they now observe a faint but distinct star, their new host sun, Proxima Centauri. This star, which they've renamed Helios, will brighten progressively as the spacecraft draws nearer. Helios, a red dwarf star, is less luminous than Earth's sun, with only 65% of its brightness. The future inhabitants of Proxima Centauri b, now officially named Novia, will experience light levels akin to Earth's early evening. Novia orbits closer to Helios than Earth does to the Sun, resulting in a year lasting only 11 days and a larger, reddish sun in the sky. To prepare passengers for Novia's conditions, the Stellara will undergo adaptations in its remaining journey. The spacecraft is currently 2.54 light-years from Earth, entailing a communication delay of 2.54 years for messages. There is also a noticeable time dilation. 60 years have passed on the Stellara, while 60 years and 19 days have elapsed on Earth. To acclimate passengers to Novia's higher gravity, the command deck initiates a gravity evolution spin sequence 60 years into the journey. Over the next 30 years, spin thrusters will be activated periodically to gradually increase the spin of the habitat ring. This increment in spin will raise the artificial gravity inside the spacecraft, aligning it more closely with Novia's gravity. The goal is for the passengers, particularly the newer generations born on the spacecraft, to be accustomed to living under this higher gravity by the last decade of the voyage, ensuring a smoother transition to life on their new home planet. As the Stellara approaches its final year of the journey to Novia, it nears the culmination of a significant transition in preparation for life on the new planet. The gravity on Novia is slightly higher than Earth's, at approximately 1.026 times Earth's gravity. This difference, though modest, will have notable physiological effects on the inhabitants. A person weighing 50 kilograms, 110 pounds on Earth, will feel as if they weigh 51.4 kilograms, 113 pounds, on Novia. The incremental increase in gravity will place additional stress on the cardiovascular system and lead to denser bones and muscles. Fluid distribution in the body will also adjust, possibly leading to increased blood pressure in the lower limbs. Over generations, these changes may result in a human species that is shorter and more compact, a natural adaptation to the higher gravity environment for energy efficiency. In tandem with the gradual increase in gravity aboard the Stellara, the spacecraft's lighting is being modified to simulate the conditions on Novia. The lights are slowly transitioning to a darker red hue, mirroring the dim red light of the new sun, Helios. This environmental change will likely drive evolutionary adaptations in human vision. The iris might evolve to an amber or gold color for better adaptation to red light, while pupils could enlarge to allow more light intake. The sclera may develop increased pigmentation to reduce glare in dimmer light conditions. This evolution will contrast with the diverse eye colors and white sclera characteristic of Earth-born humans. Amidst these scientific and physiological preparations, there are whispers among the passengers of a secretive cryolab and hibernation pods. Rumors suggest that wealthy individuals from Earth paid for cryogenic preservation to be awakened upon arrival at Novia. These stories, likely fueled by the creativity of the passengers, suggest various theories, including the intention of these frozen passengers to establish a ruling class on the new planet. As the Stellara draws nearer to Novia, the star Helios becomes an ever brighter fixture in the sky, a constant reminder of their approaching new home. The spacecraft, having carried 3 generations of humans, is now in the final stages of its monumental journey. The elders aboard, some of whom have been on the Stellara since its departure from Earth, look forward to witnessing the arrival at Novia. Preparations are now underway for the critical phase of deceleration, as the Stellara readies to complete its century-long voyage. As the Stellara nears the end of its monumental 100-year voyage, the ship and its passengers are poised for a historic moment in human exploration. Having traveled 99 years and 350 days at 4.24% the speed of light, the spacecraft has maintained artificial gravity through continuous spin. In preparation for arrival, the spin thrusters will soon engage in reverse, ceasing the spin 15 days before reaching Novia, formerly known as Proxima Centauri b. This will be followed by a flip maneuver, positioning the engines towards Novia for the deceleration burn. Over the final 15 days, the spacecraft will slow down at 1G, carefully decelerating to enter Novia's orbit. Upon arrival, Novia's gravity captures the Stellara, guiding it into a stable orbit around the new planet. The passengers, having traveled across interstellar space, have finally reached their destination. From their unique vantage point, they can still see Earth's sun, a distant reminder of their origin, while Earth's inhabitants cannot see their new red star, Helios. The ship's spin thrusters are reactivated to continue providing artificial gravity as the passengers adapt to their new life orbiting Novia. A ceremony is held to honor the ancestors and the incredible journey undertaken. During the journey, 2,924 passengers have passed away, and 5,700 new lives have been born, marking 7 generations of human existence aboard the Stellara. While 100 years have elapsed on the spacecraft, an additional 33 days have passed on Earth due to time dilation. A message announcing their successful arrival is sent back to Earth, a journey of 4.24 years each way for communication, effectively bridging time as the spacecraft communicates into the past. The next phase of this epic endeavor begins as the passengers prepare to descend to Novia using the shuttles stored in the Stellara hollow core. They will commence building their new settlement, the Novian Fields, marking the start of a new era in human history. The first 10,000 days on Novia represent more than just survival. They signify the birth of a new civilization, a testament to the enduring spirit and legacy of humanity as it takes its first steps in establishing a permanent presence in the cosmos.